Hi, we will do a regression model, then check the assumptions, the hypothesis of the regression model. Firstly, you don't need to install any package for the regression model, but later we will need for the assumptions. This is the name that I have given for the model. You can write anything here. Then little lm, you'll see that firstly here, this is the object that I use as the dependent variable. And here I use three independent variables. And here is tilde between the dependent variable and the independent variables. Run. Then writing summary will help you to see the results of the model. Here you should write the name of the model. Then run. Let's check the console for the results. Yes, here is what I have done lastly. Here is my model. So here are the three independent variables. If you need to write these results as a linear model, it will be like that. This is electricity price. Electricity price is equal to minus 772 minus 27. This is US dollars against US dollars currency. Plus 86 inflation plus 8.6 industrial production index. So these are the coefficients. The first one is the coefficient of the constant, and the others are for the independent variables. And here are the probabilities. We need these probabilities be lower than 0.05. And here is the probability of the whole model. F statistics is here, and you see that adjusted R square is here. So, assume that this model works. Now we will check the assumptions. The first assumption is about linearity, but we don't check it. We only do the model with a linear relationship. But if you are going on with nonlinear models, then you should check the nonlinearity with the test as BDS. But for this one, you don't need to do it. So the first hypothesis is the normality of the results of the model. We need to also check the autocorrelation of residuals, heteroscedasticity for the residuals, and multicollinearity for the independent variables. First, let's check the autocorrelation with the help of Durbin-Watson test. If you didn't haven't uploaded before, you should install LM test package. If you have already installed it, then call the library and run. Then writing DW test is enough to check Durbin-Watson test. Then in between parentheses, you write the name of the model that you have given, then run. Yes, you see that the p-value is lower than 0.05. That means the zero hypothesis is not accepted. So, and if you had some econometrics courses before, you should remember that the Darwin-Watson should be around 2. And so here is the assumption is rejected, and the alternative hypothesis is accepted. Let's check another one. Let's do the Brush-Godfrey test. Writing BG test is enough to write. Then between parentheses, firstly, you write the name of the model that you have given, then comma, then you should write the number of the order. So, for example, here I will check 3 orders. Let's check them. For the first one, we again check the serial correlation, like Durbin-Watson's. Here the p-value is lower than 0.05, and for the second order again, and for the third order. So 3 of the results show us that our residuals are autocorrelated. We cannot accept that the autocorrelation is 0. So the results are similar as Darwin-Watson. And let's check the heteroscedasticity for the residuals. Again, here we use the LM test. If you have downloaded, only run the library. Here we need to write some. We use BP test, but in the parentheses, firstly, you write the model's name, you should write, then put tilde, then you should write the objects which you use as independent variables. Then you should write at these formulas. For example, if you only use 2 of these independent variables, then you should delete one of them, and also the related one here, part here. So let's check the results. Here, the p-value is lower than 0.05. Be careful that all the tests here I do has same type of hypothesis, and generally we need to accept the alternative hypothesis, but here we couldn't again. So for this model, there is heteroscedasticity, but we needed homoscedasticity. Then I want to go on with the residuals. We can do a Jar-Kubera test for the residuals of the model. It's in the time series package. You should write Jar-Kubera tests. You see that it comes from time series package. Here you should write between the parentheses residuals, parentheses the name of the model. Then run. Let's see the results. P-value is lower than 0.05, so the normality hypothesis cannot be accepted. The alternative hypothesis accepted. So the residuals here do not have a normal distribution. And lastly, we did the variance inflation factors for the model. We check them for our independent variables. Is related. This formula here also covers the correlation inside it. The package we use here is CAR. Call CAR library. You should write BIF. Then LM and then the model. Run. Here are our results. Only this assumption has worked because we need the results be between 1 and 5, and you see that all the results here are lower than 5. Okay, that's all. That's finished. Take care. Bye bye.